Fentanyl. What is fentanyl? Fentanyl is a synthetic opioid. It's 50 times more powerful than heroin and 100 times more powerful than morphine. Its intended purpose is pain relief, but it has issues due to its high potency, especially compared to non synthetic opioids. Fentanyl and other synthetic opioids present a greater risk than these natural variants due to the higher likelihood of overdose. According to the CDC, 28,000 deaths have been attributed to synthetic opioids in 2017 alone, while 15,000 deaths come from heroin, which is a natural variant. But why is fentanyl so dangerous and addictive? To start, we look at the chemical structure of fentanyl. It has 22 carbon atoms, 28 hydrogen atoms, 2 nitrogen atoms, and 1 oxygen atom in its molecular formula. It is a monocarboxylic acid and comes in the form of a solid white crystalline powder. It's a synthetic organic compound with 6 rotational bonds, 2 hydrogen bond acceptors. You can see 2 examples of structures of fentanyl, one showing the individual hydrogens and the other not. Fentanyl compared to other opioids. Fentanyl has a distinct structure compared to morphine, heroin, and oxycodone, some common opioids. It has the highest number of carbon and hydrogen atoms in its molecular formula, and only 1 oxygen. It has a higher molar mass than both morphine and oxycodone, but lower than heroin. Its molar mass is 336 grams per mole. It has a lower melting point than heroin, morphine, and oxycodone by a significant amount. Fentanyl and heroin have no hydrogen bond donors, but heroin is larger, which makes fentanyl the lowest melting point. Here's an example of the structures of these opioids. As you can see, they all have a higher amount of oxygen than fentanyl itself, which only has 1 oxygen atom, compared to morphine with 3, heroin with 5, and oxycodone with 4. Fentanyl, a synthetic opioid. Unlike oxycodone, which is semi-synthetic, morphine, which is a naturally occurring opioid from opium, and heroin, which is made from morphine, fentanyl is fully synthetic. It was developed in the 1950s as a strong, fast-acting analgesic or painkiller, many times more potent than other opioids such as the commonly used morphine.
Now we look at how fentanyl works in the human brain. Its distinct chemical structure allows it to bind tightly to opioid receptors in the brain. These opioid receptors are G protein coupled receptors. That means that when the opioid binds to the receptor, the G protein inside the brain activates a cascade of events that leads to this activation of gene transcription that gives opioids their unique qualities. One of these qualities that most opioids are used for is the pain-killing effect that is caused by gene transcription in the brain. Specifically, fentanyl binds to MOP receptors, which are one of the 3 main types of opioid receptors in the brain, and it's the same type that other opioids like morphine and heroin bind to. So, looking at how fentanyl actually affects the human body, it is mainly used for pain, but there are many side effects that affect an individual who is using fentanyl. It can cause an irregular heartbeat in these individuals, and in some cases, an overdose. It can cause the heart to stop. It also can cause severe respiratory depression and often causes the human lungs to not be able to regulate CO2 levels, which can cause users to stop breathing entirely. It has gastrointestinal issues associated with it, which can cause decreased bowel motility and chronic constipation. And another huge issue is that it has dermatologic issues that cause chronic itching and skin irritation. And because fentanyl is so powerful and acts on the rewarding opioid effects, it can make people want to use it again and again after simply using it only one time. And once individuals are addicted, they normally can see withdrawal symptoms if they stop taking the drug. And these symptoms peak between 36 and 72 hours after the last use of the drug. So, we've talked about a lot of this, but we want to know why fentanyl is so much more powerful than other opioids. One of the main reasons for this is the blood-brain barrier. This is a barrier that pretty much all drugs have to pass through to affect the brain and the central nervous system. This barrier allows small fat soluble nonpolar molecules to pass right through it and go towards the brain. Hydrophilic or water loving molecules, however, are inhibited, so they can't pass through the brain as easily. Traditional opioids have hydrophilic groups that makes them harder to pass through the blood-brain barrier. If you look at the chemical formula and structure of morphine, it has two hydrophilic hydroxyl groups, or OH groups, at the end, which make it harder for it to pass through the blood-brain barrier. Heroin also has two carboxyl groups, which are also hydrophilic groups, again making it harder to pass through the blood-brain barrier. Fentanyl, on the other hand, is extremely fat-soluble and nonpolar. This makes it pass through the blood-brain barrier instantly, which is why you need so much less fentanyl to get the same effect as morphine or heroin. So this picture from earlier was the opening to our slide. And if you look to the right, this is a normal-sized penny, and those little crystals that appear next to it is the lethal dose of fentanyl in a human. That's approximately 2 milligrams of fentanyl. And by this picture on the right, you can see how much less fentanyl is required to kill a human compared to the amount of heroin, which is what makes the drug so powerful and so dangerous.
Now we will discuss naloxone, otherwise known as Narcan. Naloxone has a molecular formula with 19 carbons, 21 hydrogen atoms, 1 nitrogen atom, and 4 oxygen atoms. Its structure is displayed here. Naloxone acts within 5 minutes of entering the body. Its usage is to block the effects of opioids, which we will discuss later in the presentation. It lasts 30 to 60 minutes within the body. Naloxone has a molecular weight of 327.4 grams per mole. It has a hydrogen bond donor count of 2, a hydrogen bond acceptor count of 5, a rotatable bond count of 2, and a formal charge of 0. The reaction of naloxone and fentanyl is common among all opioids. Naloxone acts as a pure opioid antagonist. This means that it counteracts the depression of the central nervous system and the respiratory system caused by opioids such as fentanyl. This exists because naloxone has a stronger affinity to opioid receptors, making it easier for naloxone to reverse the overdose for a short period of time. A dose of approximately 13 micrograms per kilogram of naloxone produces 50% receptor occupancy in an average-sized human. Naloxone has no potential for abuse. It can be injected intramuscularly, but it is most commonly sprayed up the nose. It lasts between 20 to 90 minutes. Side effects of naloxone include narcotic drug withdrawal, cardiac arrhythmias, pulmonary edema, and high or low blood pressure. Narcan is an over-the-counter drug. It is commonly carried by emergency medical responders in response to an overdose. That is highlighted by dilated pupils, pinpointed pupils.
So in conclusion, due to its chemical properties and interaction with opioid receptors, fentanyl is one of the most powerful opioids in the world. When used properly, it has enormous potential to be a powerful tool for the treatment of pain, but recreational abuse leads to heavy dependence, addiction, and in often cases, death. Despite apparent risks to powerful synthetic opioids, even stronger variants continue to be developed, such as carfentanil,